Welcome to the Explainer. Today, we're diving into something truly fascinating. We're going to look at exactly how artificial intelligence is learning to perceive and genuinely understand our physical world. And the wild part? It's doing this by mastering the ultimate geographic mystery game. We're going to track this incredible evolution of AI, starting from just blindly matching pixels all the way to genuinely reasoning about its environment, almost exactly like a human expert would. So, picture this. If you were dropped completely randomly somewhere on Earth right now, could you figure out where you are? Millions of people play a wildly popular online game called Geoguessr trying to do exactly that. You get dropped into Google Street View and you just have to pinpoint your location on a map. Now, human experts can do this in literal seconds. But the lobby is changing. Artificial intelligence is joining in, and it's not just to play a game, it's to map out the very fabric of our physical world. All right, let's take a look at what we've got here. Can you guess where this was taken just by looking at the specific type of trees, the models of the parked cars, or maybe the gauge of the train tracks? For a human, doing this takes years of practice and a massive mental library of geographic trivia. But computer scientists realized something huge. If an AI could solve this, it would represent a massive leap in how algorithms understand global context. Section 1. The ultimate GeoGuessr player. From raw pixels to geographic places. So how did early computer scientists tackle this massive problem? Well, initially, researchers from universities like Brown and Stanford used convolutional neural networks, or CNNs. They fed these networks hundreds of thousands, sometimes millions of street view images. The whole goal was to see if the AI could somehow learn the subjective qualities, the vibe or the infrastructure, that makes a street in Paris look entirely different from a street in Tokyo. And honestly, the results were kind of mind-blowing. Early CNNs trained on over 1 million images achieved superhuman accuracy. I mean, they hit over 90% accuracy in categorizing the correct city, like figuring out it was Budapest. They guessed the correct local grid square roughly 75% of the time and had an unbelievably low margin of error for exact coordinates. That's what that tiny MSE, or mean squared error, actually represents. It was just a spectacular feat of pattern recognition. Section 2. How AI sees the streets. Peering into the black box. Now, this level of accuracy immediately raised a huge question. How exactly were these early models making their guesses? Like, what was the AI actually seeing when it looked at a street? To figure this out, researchers literally had to peer into the neural network using specialized tools just to see which pixels mattered the most to the AI. Check out the heat map on the right side. This is generated by a visualization tool called Lime, and it's showing us exactly what part of the original image the AI used to make its correct prediction. And shockingly, the AI is not looking at obvious landmarks. Instead, it's focusing heavily on a seemingly random blotch in the sky and the specific texture of the road. As this quote really hits the nail on the head, the CNNs were basically learning the most granular, subtle textures of a location. It was learning the subjective feel of a place. And because of that, it even started making very human-like mistakes. For example, researchers noticed that if you showed the model an image of Austin, Texas, it would sometimes predict Phoenix, Arizona. It recognized the broad geographic and architectural vibe of the American Southwest, even if it totally missed the exact city. Section 3, adding reasoning to AI. Hitting the generalization wall. But of course, these early picture-matching models eventually hit a serious wall. While they were fantastic at recognizing the exact roads they'd seen during training, they struggled massively to generalize. If you gave the AI an image just one street over from its training dataset, or an image without a clear view of a road, its accuracy completely tanked. It wasn't actually reasoning, it was really just matching memorized pixels. To fix this, researchers realized that, hey, not all images are created equal. Think about it. If you take a picture of a super generic brick wall, it could be in London or New York, there are literally no clues. So they introduced this concept called locatability. It's a metric that helps the model figure out which images actually contain useful geographic clues, like unique street signs, specific foliage, or distinct architectural styles before it even attempts to guess the location. Which brings us to the crucial point, the massive shift we are seeing right now in this technology. We are completely moving away from the old way of simple black box pixel regression, basically just crunching numbers on an image, and we're moving toward the new way, multimodal reasoning. This uses large vision language models, or LVLMs, combining raw visual processing with the kind of deep textual logic we normally see in advanced chatbots. Section 4. Thinking like a human. Fusing visual clues with expert knowledge. Let's see how this actually plays out in breakthrough models, like GeoReasoner and SightSense.
These newer models don't just stare at an image. They actually learn to reason by using external human knowledge. They're specifically designed to mimic the exact thought process of a human grandmaster playing Geoguessr.
So how'd they do it? Researchers basically scoured online communities and fed the AI the exact same textual tricks and heuristics that human GeoGuessr experts use every day. The AI was explicitly taught that Danish street signs have a blue background with white text, or that German wooden poles usually feature a specific white rectangle sticker. By compiling thousands of these little textual clues, the AI suddenly possessed genuine, real-world geographical context. And this perfectly illustrates the sight sense methodology. It's a really clever three-step pipeline. First, the AI scans the image and detects a fine-grained visual clue, maybe a very specific street sign. Second, it searches its vast database and retrieves external knowledge about that specific sign. And finally, it fuses that clue with the overall global context of the image, like the local weather or which side of the road cars are driving on, to logically reason out the exact location.
And you can literally see it in action right here. This is an actual output from the GeoReasoner model. It isn't just spitting out random coordinates, it's detailing its step-by-step logic. Look at the top example. It correctly identifies a blue Comfort Del Gro taxi, pairs that observation with the presence of tropical trees, and then uses that exact reasoning to confidently pinpoint the location as Singapore. It's showing its work exactly like a human detective would.
Section 5, Beyond Finding Locations. AI is learning the world. Now, why does all of this actually matter? Because this technology is about way more than just winning a geography game on the internet. It is fundamentally about AI deeply understanding our physical and psychological world. By mastering GeoGuessr, these models are proving they can actually understand complex spatial relationships, cultural differences, and entire urban environments on a global scale. Researchers are already taking these advanced computer vision approaches and applying them straight to urban sociology. By combining street view images with AI, they can cost-effectively measure how humans perceive safety in different environments. They're even using eye tracking systems combined with explainable AI to validate that the algorithm is noticing the exact same environmental triggers that make a human feel safe or unsafe on any particular street. And this unlocks some unbelievably powerful real-world tools. It gives us a massive, cost-effective alternative to doing traditional neighborhood surveys. It seriously empowers data-driven urban planning. It completely revolutionizes open-source intelligence, or OSINT, investigations. But most importantly, it shows that AI is actively evolving to be more understandable and aligned with human cognition. It's becoming capable of complex inference rather than just blind data processing.
So I want to leave you with this final thought to chew on. As AI continues to perfectly map the physical and psychological landscape of our world, gaining the ability to pinpoint any photo anywhere and understand exactly how that environment makes us feel, will it empower us to build better, safer cities through advanced urban design? Or is having a machine that can instantly geolocate any image going to completely compromise our personal privacy? Thank you so much for joining us for this explainer, and keep questioning the world around you.